Welcome to your ultimate AI cram session. Look, if you are feeling totally overwhelmed by that massive syllabus, just take a deep breath. We've got this. Today, we are going to take an entire semester's worth of artificial intelligence and distill it right down into the absolute high-yield concepts you actually need to ace this exam. Think of this explainer as your master's study guide, totally packed with the exact source material you need to know.
I'm essentially your virtual teaching assistant today. But before we jump into the deep end, I really want you to ask yourself, are you truly ready to define, compare, and apply the core principles of AI? Well, if there's any doubt, let's fix that right now and make sure you walk into that exam room with absolute, total confidence.
All right, here is your exam blueprint for today. 1. Foundations of AI. 2. Intelligent agents. 3. Problem solving by search. 4. Structuring AI knowledge. And finally, 5. Major branches of AI. Let's get right into it.
Starting off with Section 1, Foundations of AI, Evolution and Concepts.
Okay, so if you get a multiple choice question asking who the father of AI is, you literally just need to remember one name, John McCarthy. He's the one who actually coined the term artificial intelligence way back in 1956. And you really should know his exact definition. He called it the science and engineering of making intelligent machines. Basically, it's about programming machines to simulate human intelligence so they can think, learn, reason, and solve problems just like we do.
Now, you're definitely going to want to keep this historical timeline in your back pocket for any chronological context questions. The whole journey really kicks off in the 1950s with Alan Turing, the famous Turing Test to see if a machine's behavior is indistinguishable from a human's. Then fast forward to the 1970s, the focus totally shifted to expert systems that tried to mimic human specialists. In the 1990s, we saw massive advances in machine learning, where computers actually started learning from data instead of just strict, predefined rules. And that brings us to the 2010s and today, the era of deep learning and generative AI, which gave us the crazy powerful tools we're using right now.
All right, listen up, because this is a classic compare and contrast exam question for sure. You absolutely must know the difference between narrow AI and general AI. Narrow AI, which is also called weak AI, is what we actually use today. It's incredibly capable, but only within a very specific, limited domain. Think of Siri answering your voice commands, or how your email filters out spam. General AI, on the other hand, also known as strong AI, is completely theoretical. It doesn't actually exist yet. This would be an AI with true human-level intelligence across multiple domains, able to seamlessly transfer its knowledge from, say, complex math to diagnosing diseases.
Moving right along to Section 2, Intelligent Agents and How AI Interacts.
If you have to write a short answer definition on the test, just memorize this verbatim, okay? An intelligent agent is a system that perceives its environment through sensors and acts upon that environment through actuators to achieve specific goals. That's it. It's just a constant cycle of taking in data, reasoning about it, and then taking action. A self-driving car trying to navigate a busy city street is honestly the perfect textbook example of this.
And if your professor asks you to list the actual components of an agent, use this exact breakdown. First up, sensors. These are things like cameras and GPS that collect the environmental data. Second is the agent program. That's the actual brain that processes all that data. Third, you have the knowledge base, which holds all the rules of the road. And finally, actuators. Those are the mechanical parts like the steering wheel and brakes that physically carry out the AI's decisions.
Let's jump to Section 3, Problem Solving by Search and Search Algorithms.
So professors absolutely love testing on processes. If you see a question about how an AI searches for a solution, like a GPS calculating a route, you need to remember these 4 sequential steps. First, define the problem. Second, identify the initial state, which is really just your starting point. Third, specify the goal state, meaning exactly where you want to end up. And fourth, determine the possible actions or the different paths available to actually get there.
Okay, put a massive mental star next to these 2 search strategies because you definitely need to distinguish between them. Uninformed search, which is also called blind search, just explores every available path without any extra clues. Examples here are breadth first or depth first search. It works, sure, but it eats up a ton of memory and time. Informed search, on the other hand, uses a heuristic, which is essentially just an educated guess or an estimate of the cost to get to the goal. It finds the optimal path so much faster. A-star search is absolutely the most famous example you'll see of this.
Next up is Section 4, Structuring AI Knowledge and Organizing Data.
A really heavily tested concept in this section is the semantic network. Think of it essentially as a visual web. The nodes represent ideas, objects, or concepts, and the links, or the arrows, represent the specific relationships between them. It's cleverly designed to represent knowledge in a way that's actually super similar to how our own human memory works through complex associations.
Now let's see how this builds into a totally incredible reasoning tool through a crucial concept called inheritance. Just look at this logic. A dog is a mammal. A mammal is an animal. The system already knows that animals have life. Therefore, through inheritance, the AI can logically deduce that a dog has life, without a programmer ever having to explicitly type out, "Dogs have life." This is a huge deal because it saves immense amounts of memory and completely prevents redundant programming.
When you're asked how AI mimics human experts, like, say, a medical diagnosis system evaluating a patient's symptoms, you need to list these three major components of an expert system. First is the knowledge base, which stores all the expert facts and the if-then rules. Second is the inference engine. This is the processor that applies logical reasoning to those facts so it can reach a concrete conclusion. And third is a user interface, which is what allows the human user to actually communicate with the whole system.
And finally, Section 5, Major Branches of AI and Applied Technologies.
You guys, consider this breakdown your ultimate cheat sheet for machine learning. You absolutely have to differentiate between these three paradigms. Supervised learning uses labeled data where the correct answers are already known, like feeding an AI thousands of emails specifically labeled as spam or not spam. Unsupervised learning, though, uses unlabeled data to find hidden patterns, like an algorithm grouping customers together based solely on their purchasing habits. And then reinforcement learning trains an agent through a system of rewards and penalties. That is exactly how game-playing AI learns to beat human champions.
For the second branch, natural language processing, or NLP, just remember that this is the technology powering the tools you use quite literally every single day. Google Translate, chatbots, voice assistants. It works by analyzing the syntax, which is the grammar, and the semantics, the meaning of human language. That's what allows machines to process our messy, complex speech and actually generate human-like responses.
Moving to the third branch, computer vision. You must know these sequential steps showing exactly how a machine interprets visual data. First, image acquisition, snapping the picture. Second, image pre-processing, cleaning up the image by removing visual noise or adjusting the brightness. Third, feature extraction, identifying core patterns, edges, and shapes. And finally, object classification, actually determining what is in the picture. This could be identifying a stop sign for a self-driving car or even spotting a tumor in a medical scan.
For the final branch, robotics, the big takeaway is that adding AI to physical machines is what finally allows them to operate autonomously and adapt to changing environments. Traditional robots just blindly follow fixed instructions, but AI-powered robots, they're used in manufacturing for precise assembly, in healthcare to assist in delicate surgeries, in agriculture for automated harvesting, and even in space exploration, like those Mars rovers navigating totally unknown terrain on their own.
As you head into your exam, I want you to keep this fundamental ethical question in the back of your mind. If AI systems are built to autonomously learn, adapt, and make decisions, who is ultimately accountable when they make a mistake? Because understanding how AI works technologically is honestly only half the battle. Grappling with the immense responsibility of creating it, dealing with privacy, bias, and accountability is just as crucial. All right, you've got the core concepts down perfectly. Now go out there and absolutely ace that exam.